All right, today's a computer science speaker. Just for our guests, we merged ECE and CS seminar so that we could have more speakers from just various backgrounds and make sure that those students can work together too. So thank you for joining us, Stephen. So Stephen Amore is the founder and chief technology officer of Alpha 6 Corporation, or I think you still are. Is that right? Okay, well, I don't know. I pulled up this bio and I'm like, I didn't date it, you know. But just generally security work with the federal government for a long time. You're ultimately the company you started. I thought was bought by somebody. Was it
Chris Security bought by
by Harris? By Harris, yeah. Is it still called Harris? It might be something else now. I don't think it's still called Harris. Um, and is one of our Virginia Tech alumni in computer science from the late 90s, we'll say. But anyway, he's going to tell you about his journey and also some of the technology that he works with readily. And so we welcome Stephen to our group here. Thank you.
All right, thank you. All right, so first thing, by show of hands, how many of you feel anxious about using AI for your coursework because the rules seem kind of blurry? Anyone? How many would raise your hands if there were no faculty here? That's okay. This is kind of a difficult time to walk that line because your professors are trying to teach you the core tenets of engineering and sometimes make you do things the hard way to teach you the right way to do things. But you're going to find when you flip over to industry that line kind of switches and there's no more points for doing it the hard way. They care more about your efficiency and effectiveness and doing things the correct way, getting the correct results. But if you do it the fast way and don't keep those engineering principles, it's going to be a big disaster. And so that's what I really want to talk about today, that AI is easy, engineering is hard, but that's going to be your advantage. So, there's a lot of talk on, hey, how is AI going to affect computer science and computer engineering? Is it going to take away our jobs and that sort of thing? And I think that taking those principles that you're learning here in engineering and being able to apply those are really going to be your superpower when you go out into the working world. And it's going to help you be very valuable to be able to build things at scale fast, but also correct and working well. So I hope at the end of our talk here that you're going to see that and have that same opinion. So a little bit of perspective on who I am and how I got this kind of view. As he said, I was a CS graduate. I was actually here at the beginning of the 90s, 90 to 95. I've spent about 30 years building large solutions and systems working in the kind of government environment. And throughout that time, I've kind of seen three big things. The tools always get faster, systems get bigger, and failures get more and more expensive. And I see the same cycle of fears that you're seeing right now with AI have been repeated over time throughout this sort of career and seeing things continue to break at scale. So when I go to alumni events, I always like to go up to the people in CS or computer engineering that were before my time and see what was it like in their time before I came to tech. So I thought I'd share a little bit of that with you guys today. So the computer that we got as CS majors was an Amiga 3000 UX. So it came with Amiga OS on it, and it also had an AT&T Unix on it, which was the opposite of Linux in that it was closed source. You had to have a very tightly controlled licensing to get at it. And I kind of put the specs here of that computer versus what you guys have on a laptop. So the picture on the right is a pretty accurate rendition of how big it was. It was definitely not something you could move around, but having 4 mega RAM, 100 meg disk, we had a 14.4K modem, which is about 0.014 megabits per second. We didn't have Git. There was no Google. I never had a debugger. There was not a bunch of open source libraries that we could take advantage of. I think the Linux kernel was released in 1991, but I don't think I remember hearing about it until I was maybe a senior or my first year into working. Compile times on some of my projects would take 30 or 45 minutes just to compile So we had to be really good. We focused more on getting it right before you compiled than the whole doing your testing after, just because it took so long and the feedback loop was so long. But even with all that, we thought we had it easy compared to the generations that came before us. So I talked earlier about that kind of cycle of fear that you see in computer science over time. So starting in the 60s and 70s, they moved from punch cards and flipping switches to enter commands into getting high-level programming languages and terminals. And the old timers would say, oh, that fast feedback is going to make everybody lazy. And then in the 80s and 90s, they got things like IDEs and C and Unix. And now it was the tools are going to keep you from knowing what's really happening on the hardware. And then in the 2000s and 2010s, it was open source and cloud and DevOps. And everyone said, oh, now you're just stitching things together. You're not really, building from scratch and making sure everything is optimized like we used to. And now you have the AI age with LLMs and copilots. And obviously the fear everyone has is that the tools are going to make all the jobs disappear. So the hard part has always been there, but it just keeps moving. So for my career, I started out in computer security. I was a co-op student when I was an undergraduate at the NSA, and I did a lot of stuff with things. And what I can actually talk about is that I did Unix vulnerability research. So that kind of got me interested in computer security. And so from there, I went to work for the MITRE Corporation. And I did everything from forensics and malicious code reverse engineering to red teaming and intrusion detection. I got to do fun things like go around to military bases and plug in my laptop and see what I could hack into. Except in those days, it was really like shooting fish in a barrel. I mean, you wouldn't believe how open computers came when you bought them. I mean, they would literally let anybody log in without a password when you'd first plug them in. It's very different than it was today. So after MITRE, I helped start a company called Crucial Security. We worked a lot with federal law enforcement. I was continuing to do the forensics, malicious code reverse engineering type of work for like counter intelligence and criminal cases. Then 9/11 happened, and the amount of data we started getting was bigger and bigger. So I shifted from kind of being an individual contributor into building tools so that we could scale for all the analysts and agents to be able to do something with the data. So I shifted more into building those apps to be able to handle more data, and had to start thinking more about user interface, reliability, and all those kinds of things. Then we ended up selling that company to Harris, and after a few years, I left and helped start another company, Alpha 6. And there we continue to do government type of work, but there we really focused on big data technologies. So things like Hadoop, Elasticsearch, MongoDB, again, taking lots and lots of data and making it available for the analysts to do something with. So every time my career kind of shifted was because the scale kept changing. So we would build something, too much data would come in, it'd break, we'd have to re-architect it, and then too much data would come in again. So this constant cycle of continuing to have to grow things and add in new tools and technologies. So the most important thing that I always tell people about my experience here at Virginia Tech was not a particular language that I learned or a class that I took. It was the ability to solve problems. That's the thing that's really served me the best as I've moved out into my career. And so over time, my role shifted to more of an architect and team lead and managing people and doing system design. So I still knew how to code in my head, and I knew how to design systems, but I kind of lost track of the syntax. And so I lost my ability to program. Then AI came along, and now all of a sudden using the tools, I can magically program again. So it's great that now I can really get the feel of building whole systems with the assistance of those tools. So I'll talk a little bit about my AI arc. So when ChatGPT and those things came out, I first started out by, give me a recipe for this, or what should I go see in this city? But then I wanted to find something kind of interesting to do with it. So I decided I was going to try to solve some math proofs for some problems that were out there that hadn't been solved. And I've kind of talked to Christine about it, and I think she thought I was a little insane at the time when I was telling her what I was trying to do. But I started out with the typical, web UI to ChatGPT and that sort of thing, and it was fun and it was fast. But after a few hours, it would lose memory of what I was trying to do. I would have it print out LaTeX formatted stuff for me to put into a notepad, to then put into a compiler, to turn it into a real document, and then those would get out of sync. So I didn't have any artifacts in it. And then I finally got to one where I could have it actually create files and let me download files. But then again, overnight, I'd wake up in the morning and it had wiped all my files, behind the scene. I didn't have any control of it. So then one day I finally figured out that behind the scenes, the AI was doing most of it by creating Python code and then having the Python code implement whatever it was that I was trying to do. So then all of a sudden I thought, hey, I can take Google Colab and I can take the AI and I'll have the AI just give me the Python code. I'll stick it in Colab. I can run it there. I can save my documents into Google Docs. And then now all of a sudden I have my artifacts. I can see the code and have a much better idea of what's going on behind the hood. But there, I still ran into problems where they would get out of sync and it would have compile issues. And then the AI was imagining what was really going on. So it still wasn't good. And then finally, along came the CLI tools like Claude Code and that sort of thing. So now I had the aha moment where now on my own laptop, I could control everything. I could keep the documents. I didn't have to worry about them getting erased. It wouldn't get out of sync. So that was a beautiful moment. So I didn't get better results from prompting better over time. It was starting to put systems around the prompting that allowed me to advance in what I was doing with the AI. So I like to say AI is so smart, but so dumb. I love AI. It's great at so many things. It's got such a breadth of knowledge, its ability to synthesize things, its speed, and I already mentioned the syntax. But you can look at the pictures on the right. I actually asked AI, I said, show me something that a hammer is good at and something that it's bad at. And this was the picture that it came up with. So, look at the detail, the hammer, the metal, how the nail is going into the wood. So many of the details are great, the photorealism. But then I'm not really sure what's going on the right there. If it's trying to say a hammer is bad at nailing it, putting a nail through a cup of coffee or stirring a cup of coffee. So it did my intent, but it wasn't really what I wanted. So AI is bad at remembering intent. It's bad at respecting constraints. It loves to take shortcuts and also owning outcomes. So there's a quote down at the bottom, and I don't know if you guys can read it or not, but I was actually talking to the AI, and the AI said, the ironic part, we just documented that upgrading testing is mandatory and then completed without the upgrade testing. So, so even though I told it what to do, we talked about what to do, it documented what to do, it still didn't do what I asked it to do. So that's where we get into systems. So I think that's the wall between amateurs and people that are going to be super successful with AI is whether they put systems around their development versus they're using prompting. So prompting is very ephemeral. It requires constant correction and it scales poorly. Over time, it starts to forget things. You start to forget. It's very frustrating. But if you start to put systems in place, you're really encoding intent. You're trying to enforce those constraints and put a lot of guardrails and keep the AI focused on what you really want it to do. And then that's where you really get the leverage to now use it to do much bigger projects. So I don't want you to think of AI as an oracle where you're talking one-on-one to this being and it's solving all your problems. You really should think of it as your own personal team. You've got a developer, you've got a tester, you've got a tech writer, all kinds of different roles. And that's also an advantage. And then it's given you experience of managing a team and managing different people. So before you get into it in your career. So you're getting a lot more experience in that before you start out in the industry than we got back in the day. So engineering has been organized around a certain set of principles since the beginning, back into the Roman days probably. So things like making sure you have requirements, writing down documentation, version control, doing reviews, verifying that it was done correctly. So whether you're building a house or you're writing a computer program, all these engineering tenets are very important and are going to be key for you being able to be successful. So the tools may change, but good engineering doesn't. And you also need to have artifacts. And so artifacts is like if I'm have an electrician putting in wiring into a house that I'm building, I'm not just going to trust him and say, he says, okay, I'm done. You want to go and see, I'm going to check that the outlets are at the right place. You want to set the wire, looks like it's properly shielded, all those sort of things. You're going to test the outlets. You're going to test and get results that show you that it was done correctly. So artifacts is a key part of this whole systems thing. So the right system can come in and really make things good for you. So there's a bunch of systems out there that you can get for free that are open source. Two of them I'll just mention here, Superpowers and GSD are some that I hear a lot about. I happen to use Superpowers a lot, and a lot of the stuff I'll talk to you today about is kind of built around that. But there's many of them out there that you can go out and try. And so these really start to help you put those engineering principles into place as you're using AI for whatever your project is. So diving in a little bit more into Superpowers, it starts out with, it's got a collection of skills. So the first one is brainstorm. So you tell the skill, hey, this is what I want to do. I want to start a new project. I want to fix an issue. I want to add a feature. And then it goes off and it thinks about it and it comes back and it starts asking you a lot of questions to help dial in exactly what you're trying to do, what requirements you have, what kind of testing you want to do for it, and that sort of thing. Then it takes all of the items that is discussed with you in that conversation and it writes out a design document that codifies into a file everything that you want to build, and then an implementation plan that is your way to actually implement what your design was. Then it has an execution phase where it can launch a bunch of sub-agents to work on those tasks and take part in doing what the implementation plan was. And it follows what's called TDD, test-driven design. And the philosophy there is before you write any code, whether you're doing a fix or adding a new feature, you write a test that fails because you haven't done it yet. Then you write the minimum amount of code to make the test go green. So now you know you're doing whatever it is you were trying to do. And then you refine it to get it better, the code that you wrote, and you still have that test there so you can keep checking that that test stays green so you know that it's still working. And then finally, the concept of code review. So when you're done, somebody come in and review it. If you go back to that engineering slide we had, you can see, it follows that same kind of model of coming up with the requirements, executing it, doing the test-driven design, and then reviewing it when you're done. So now I started to have systems and I wanted to build some software with it. So I had my superpowers and I started, and I would say use brainstorming skill to do this. And then I say use the plan writing skill to write my plan. And I was doing all those and it was fast and fun, but it didn't have memory. It would forget things. I would forget to add stuff into the prompt that I wanted to do. So that was my kind of version 0. And then so from there, I moved into a copy and paste where I had a Word document on the side and I built up kind of a meta prompt around the superpower skills where I would say, hey, I'm going to give you a list of issues and I want you to follow these steps in fixing the issues. I want you to use the brainstorming skill, then write the design, then I want you to do testing. Don't forget to follow TDD the whole way and all those sorts of things. So now I, have that in place and you would think, okay, I'm good, I'm golden, I've got my system, but wrong. Still the AI wasn't doing exactly what I wanted. So this whole journey we're going to talk about is going to be an evolution of failure. So I decided I needed to turn the prompt into a skill. So I used the brainstorming skill from Superpowers and said, hey, take this prompt, let's brainstorm about it, let's improve it, let's put in more guardrails, Before, when I was doing it, it was probably missing about, you know, 50 or 60% of what I was trying to do. It would get done, and I would say, "Oh, did you follow TDD?" And say, "Oh no, I totally didn't follow TDD." Well, I instructed you to follow TDD, but you forgot it. So here you're going to see again that kind of structured workflow where the first row is we analyze and design, the second row is we execute, and then the third row is we verify. And this is not designed to be a totally autonomous flow. We have user gates so that after the design and plan, it comes back and it presents it to you. So then you can review it and make sure the AI has got the right concepts and how you want to do it. And then it executes and tests. And so that's part of sort of autonomous from there. And as you can see, I'm really great at naming things, so I called it my issue fix. So now let's dig into the different phases. So the first phase is it's either I'm asking it to fix a bug or add a new feature. So if it's a bug, Superpowers has a great troubleshooting skill that'll go in and try to figure out what's going wrong. But the first thing we want to do is actually be able to reproduce the bug, document what the bug is, so that we know the AI knows exactly the bug I'm talking about, because it loves to hallucinate. And if you just say, "Hey, fix this bug," and you don't have it actually reproduce it first, it may be the right bug, it may not be the right bug that it's trying to fix. So then it goes through and it reads a lessons learned document. So I've tried to turn this into kind of a self-growing knowledge base of things to do. So after we get done with every pass, I have the AI go back and analyze what it did and say what went wrong and what we did and what lessons did we learn from this. And so it starts adding those into a file. So here at the beginning of the process, we're reading in that lessons learned file and saying, which of these do we think will apply to this process so that it won't repeat past mistakes? Then we go through the brainstorming. We start building up the criteria and the specs of what we want to do. We remind it when we build the design and build the implementation plan to make sure you're doing TDD and code reviews and all those sorts of things. And so then, as I said, once it gets done with all that, it creates the design and now comes back to us and says, "Hey, is this what you want me to do?" We say yes, and then we move on to the next thing. Now, this is probably one of the most key parts of the whole process is the design document. And so it's going to take that and it's going to write it out on disk. We're not going to trust it to keep in memory. A lot of times, by the time we go through all the brainstorming and the back and forth, it's almost to the end of its context window, and it's going to end up being compacted, and it's going to forget key elements of the design. So we want to make sure that that gets written to disk so that later on in the other phases, we can read that design back in and refresh its memory to make sure it stays on track. So that design document is going to have all the things you would expect. It's going to have the architecture, the goals, the error handling, what we want to do, and also what we don't want to do. It's going to generate a state-by-state win clause for the specs. It's going to any security considerations we have in there, like, hey, we want to make sure this is encrypted. We want to make sure we use this kind of authentication method for logging in. And then also make sure that it takes into account documentation. So a lot of times you build big enterprise applications and you add a new feature and you build some documentation for it. And then you go through a bunch of iterations where you update the feature and you forget about the documentation. And so now your documentation is out of sync with what the system actually is. So we try to build it in to make sure that as part of this process, whatever it changes, if there's any documentation associated with it, or if it needs to generate new documentation for it, that it includes that as part of its work. So every future phase is going to read from this, and I like to say that context gets compacted, but files don't. So now we're in phase 3. We're doing the implementation plan. And so it's going to take the design and split it into a bunch of small tasks that are easy for it to complete and follow. And so it doesn't get lost trying to do too much at once. We're going to make sure that plan includes multiple code reviews in the process, make sure it has a security review. We're going to have it go through and try to come up with a full testing suite to be able to apply when we're done. And it's not just the happy path of, what is it supposed to do? We want to look for edge cases and look for interface contracts and make sure that those things are tested as well. And then one thing I've really been leaning into a lot lately is this adversarial review. So the LLMs all want to please you. So if you tell it to write the plan, and it's going to try to write, a good plan and do a good job at that. So then we flip it around and we say, okay, now I want you to take an adversarial review of the plan. I want you to rip that plan apart and find what's wrong with it. And it wants to please us, so it'll actually go through that. And it always finds some things. And I wonder if I really need to do that 2 or 3 times. I only do it once right now, but I've found it gets really good results by taking that adversarial approach to doing it. And again, this is one of the user gates that we run into. Now, we've done a brainstorming, we've got our design, we've got our implementation plan, but before we execute, we're going to remind the LLM of a couple of key things. Don't forget to do these things. One is, back in the first phase, we wanted it to ask us the end-to-end testing. That's everything from like user logs in, goes to this screen, clicks on this button, and this should show up. And we'll have lots of these end-to-end tests for the system. Doing the end-to-end for the whole system could take a really long time. It's great for regression testing. So if you fix something over here, you can run the whole regression test and make sure the rest of the application is still working. But sometimes what we're doing is pretty tightly focused on a particular area of the code. And so we can tell it we just want to do kind of a narrow end-to-end testing to save a little bit of time. We also want to make sure we never have it merge to main and never clean up to branches. There's a lot of horror stories out there where the code decided, hey, I don't need these couple of code files anymore, and then it writes directly to main, and now the company's lost, half of their code base. So word to the wise, don't let the AI merge to main, and do extra backups in GitLab or GitHub or whatever. Actually go in and do the settings to not allow writing directly to main as well. You'll be happy one day that you did that, I promise you. And so we're trying to say, these are not preferences, these are prime directives. You have to follow these things. Because now's the time to tell it. Once it starts getting in and executing, it starts to feel pressure. My context window is filling up. I got to finish this before that happens. And so it's going to start making bad decisions to try to get done. So we want to make sure we reinforce here these key things. Now we're going to actually implement the plan. So the first thing we want to do, as I mentioned earlier, it's probably gone through compaction by this point, even though nowadays, like Claude Code and some of them have gone to the million token context window, so it happens less frequently. But we want them to read in that design and the implementation plan again, just to make sure we're recentered on what we want to do. We're going to make sure it's doing it's going to go off now and do the TDD testing to make sure that as it adds new code, that it's doing it the right way and meeting testing. And we're going to do a code review right after the TDD just to look at the quality of the code. And then we're also going to, later on when we do more testing, in case we find things that need to be fixed in that testing, we're going to do another code review later. And here's another big advantage of the AI as your team, like we were talking about earlier. In the old days, before we had AI, you would have a tester and you would have other coders. And so if you want to go through this process, and every time I write something, I got to hand it off to the tester, and then he comes back to me, and then I got to make my changes, and then I got to go over to my coder, and then she makes her changes, and then she comes back. And so it would take a lot of time. But now when you have your own team, everything flows seamlessly. You just got to make sure you're implementing those various team members. So we're also going to make sure as we're doing the coding that we're coding against what really exists, not just what the AI thought it was. So every once in a while in the design for this, like a schema of a table, the AI will hallucinate what it thinks the schema is. So here we're adding in a check to make sure that we go and actually look what is the schema and that we're coding against it when we're writing our code. We're going to make sure, in the Star Wars famous line, stay on target, make sure it's not taking any shortcuts. If it finds other issues that come up, it can ask us about it, but we don't want it to just go off and start working on them. And then after the implementation, we come back and launch a couple more agents to do things like try to simplify the code and that sort of thing, make sure we're being as efficient as possible. So now that we've finished our execution phase, now we're into the testing phase. So passing is not the same thing as correct. So we do a couple of gates where we want to look at the infrastructure to make sure, we just wrote code. Like I do a lot of work with containers. I want to make sure that they actually rebuilt the containers with the latest code. They love to test against the old containers you have running. We want to do an environment check and say, hey, if in production we have a database and a UI and a server and all those sorts of things, in our dev environment, we should have all those same pieces as well. So make sure that the testing we're doing in our dev environment matches what's in production. If we need to generate seed data to do the testing, we'll actually launch a sub-agent. So it's got no context of what the design or the implementation was. It just knows, hey, I need some seed data that matches these sort of specs. And it's going to go off and generate that seed data for us. Then we've got we're going to verify that it did the TDD and that sort of testing that we wanted to follow. We're going to do the security review to make sure that it's following good security practices. Pretty much anything you do, you should do a security review of. Everything is security dependent in some way or another. It's actually going to go in and kind of start to take that adversarial check again, where it's going to say, can I mutate the test? So some tests, it might be a greater than or equal, and both those tests would pass, but they're not both necessarily correct. So making sure the tests are really correct to what we're trying to do. And then after all that's done, do another adversarial pass and say, hey, what do you think could still break based on what we've done? And then we can go back and handle it from there. So finally, we're to the last two phases, verify and learn. So here, again, we're going to reread the design and the implementation plan. So we're going to get all the requirements that we generated back in phase one. We're going to check and make sure that what we developed met all those requirements, met all the specs. We're going to make sure there's actually evidence of it. It's not just the AI telling us that it did it. You got to show us evidence that you did it. We're going to make sure and review the code review and security reviews that we did. And then once we're all done, this is where, as I talked earlier about updating the lessons learned, we're going to say, hey, review the process we just went through. What mistakes did we make? What would you have done differently? And when we're putting in those lessons learned, we're doing it both at the specific and the generic level. So whatever the specific thing that it did wrong, we want it to do that, but we also want to kind of broaden it out into what class of mistake was this? So if there's another mistake that's not that exact same mistake, but a similar class, we want to be able to catch it when we come back later. And then finally, we're going to update a bunch of project artifacts. So if we added any new documentation, I have a documentation map MD file that I keep so that the system knows how to find it. A project map so that it has where all the source code is. So if we added any source code, it's in there. A lot of times the AI will spend a lot of time, you think you've been working with AI on your project for 6 months, that it knows where things are. It doesn't. It's totally forgot it. You're going to come in tomorrow. But if you have these artifacts like this, the project artifacts and documentation artifacts, it makes it very easy to help get it back on track. So if I'm doing things like, hey, I want you to build me an upgrade bundle, but first I want you to review the lessons learned. I want you to review the process docs and look in documentation map.md for where all those things are. So then it can quickly go and find them. So now we started out, I was doing just the ad hoc prompting. Then I started the copy paste from the meta prompt around the superpowers. Now I've got this awesome skill that I went through all this brainstorming and added in all the good software engineering stuff that I learned at Tech. So I've solved all my problems. Wrong. Even with all of that, it still would forget and skip about 40, 50% of the steps that I'd put into that long skill. So I went back and brainstormed it again, and the idea we came up with was something called progressive disclosure. And so what we did is we turned it into a bunch of sub skills, and we have kind of a thin coordination layer across the top that just does a little bit at a time. So we took the 700 line skill and broke it into a bunch of smaller skills. And so that way we weren't overloading the context and overloading the AI with too many commands all at once. So now we've done all these things before. We got the micro skills. We're up to about an 80% skip rate, but still not perfect. It's still forgetting things. So now at this point, I'm like, well, I can't break it any smaller. What am I going to do? So there's a couple of things that are fundamentally true about today's technology with LLMs. One is they're really optimized for completing the task, not for doing the task exactly as you told it, as you've probably got from what I've been saying. And any kind of external enforcement that we can put around the LLM is better than asking the LLM to self-police itself. And the third thing is if we can do detection while it's actually in action is better than trying to build it into the initial prompting for it and preventing it at the point of instruction. So the LLM can read the rules, can rationalize it, and then decide, hey, the user doesn't really need this, I'm going to skip it. So from there, I went and added hooks. So skills are basically prompts that get loaded into the LLM context. They're subject to compression and rationalization. As I said, the AI can read them and decide to skip them or not. Hooks are actually external scripts that are built into the tool that you're running the AI with. So if you're in Claude code, it's the CLI that's managing the hooks outside of the AI. So the AI doesn't have any control of them. Hooks aren't compacted. And so it gives you a really good way to check in on the AI and try to force it to do what you want to do. So I then went and added a bunch of hooks into the system. So the first one is an auto activation hook. So it watches for whenever I run my issue fix, and then it sets up all the other hooks to activate. And then it goes through an initial phase gate. So it blocks you from writing to any code files until you have your implementation plan, your design, adversarial review, and the specs and that sort of thing actually written out to disk. And then once you've got all those things done, then it'll change the state of the enforcement. And now as the LLM is going through the execution phase, then it does a periodic check-in. So I have it at every 50 tool calls because I'm trying not to slow down too much. But you can set it to whatever kind of number you want. And it's basically checking in at each of those saying, hey, are you following the plan? Did you remember to do these things? Because the LLM is pretty honest. It'll get through. It'll make a mistake when you're done. Like, hey, did you do that? Nope, I totally ignored it and didn't do that. So it's shameless about admitting its mistakes. And so if you come in with the hooks and prompt it in the middle execution, you can kind of get it back on track. Then when it thinks it's done with the process and it's trying to stop, the final hook comes in and it checks the transcript of what went in the session and make sure that all the evidence files are there and make sure it did all the things you want to do, make sure that it restarted the environment to test with, and that it actually generated test results. It didn't just write the test and not get any results from it and tell you when to stop there. And then the fifth hook I added was just whenever we compact or if you resume a session, that it takes those documents and will re-inject that state from disk. Or if you had a crash session, it'll clean it up for you. So now this is where I am today. So I've made it through all the way through the evolution of failure down to hooks and enforcement. I think it's probably about 95+%. It would if I asked the AI, it would say it's 100%, but I don't really believe it. But it's pretty good now. I see a lot less failures. I feel like I'm able to progress through the system. And so, this particular system is not perfect. I'm not saying you have to use this system. I just want to show you guys, how a system can work and how it can make it better for you. So as I said, I found that as I progressed from just doing the prompts, about 40 to 70% skip rate, to once I got it all into the big skill, I got it about 80% right, only about 20% skip rate, and then finally about 90%, 95% with the hooks. So what should you do with all this? I would contend that you should take AI and you should go out there and build something. I really think you guys are living at the greatest time in the history of the world to be an engineer in a computer related field. There's no barriers for you to go off and do great things. A lot of the things that held us back in the day aren't there for you with these tools. But as you're doing it, force yourself to remember the principles that they're teaching you here at Tech and apply them to the process. Because as you can see, it was very easy to not do it and think you're making, you hear people one-shotting things all the time, but real systems aren't going to scale and aren't going to work that way. So now we're to the end of the talk. And hopefully, I've showed you that AI is easy, engineering is hard, and that's the advantage. Don't compete with AI at what it's good with. Win at what engineering has always made successful and is always required. So I know you guys are all capable of going out there and making a huge impact in the world. As Steve Jobs said, go out and make a dent in the universe and go Hokies. Now I'll take any questions if anyone has any. Thanks.
All those things.
Yeah, so I have been building an application at work for about the last 6 months, and I've actually been using the $200 a month plan. So it's been costing me about $200 a month, and I do it mostly on my laptop. We do have a little lab at work with some servers that I have VMware running on it, that sort of thing. So it doesn't have to be, expensive. Now, if you're, building a big system that's going to have big data and that sort of thing, once you get into production environment, that's super expensive. But I would be judicious about trying to use as many subscription services versus paying for the API route as you can to save money.
Other questions? Yeah, go ahead. Some of the questions coming in.
Yeah. Thank you very much for the talk. So I have a question here. I want to know, how do you control AI use with the development team?
Oh, with the development team?
Yeah.
So I'm not exactly sure. So we encourage the AI use. So we're not trying to keep them from not using it. We do try to, make sure, as the last question was, that we're making judicious use of the subscription services and that sort of thing. And then just making sure you build in this, type of engineering system process so that whatever there is building is not just AI slop. But we encourage even, we have non-developers within the company. We encourage them to, use AI to try to make themselves more efficient and effective as well.
I have another question from Paul. I'm old school. Any process usually has some parallel subtasks. Does AI handle critical path method and write a Gantt chart?
So I don't know the exact answer to that. You can build your process to be whatever it is that you want to do. So I think what the superpowers does, where it breaks it into tasks, it breaks it into phases, and then task 1, 2, 3, 4, 5, and then 1.1, 1.2. So that, would very easily lend itself to a Gantt chart. So certainly, if you wanted to codify kind of a different, you could do more of an agile sprint type of thing. And using Git to make sure you're able to safely merge things back in. I didn't really talk about work trees too much, but also making sure you use work trees. So that gives you your own little copy of the code. You can do whatever you want in it. And until you're ready to merge it back in, it doesn't affect anybody else and doesn't affect the main software. So another safety tip there. But yeah, sure. You could do a Gantt sort of solution.
Thank you. Any other question in Zoom?
Yeah, I had a question. Can you hear me?
Yes.
All right, so I have I don't know, there used to be some other folks in the class, but there's a class being taught by a professor that just left here, coding with AI basically. And he's working on a project that's very similar to what you're doing here. So I was really more interested in if you would share any of the skills you have, or if you publish any of them on Claude or anything like that, or
So the superpower skills, you can just Google, get superpowers. And I think it's OBRA, OBRA, and that, or the GSD. I said get stuff done. I don't think the S is really stuff. But those are both off of Git. I haven't published mine. I haven't been brave enough to publish my own skills yet. Maybe at some point I will, but I haven't done that so far. But a lot of these CLIs have a great built-in capabilities to help you build a tool. So a lot of these skills, whenever I want to build, like I build one that I use my fantastic naming skills. I call it my adversarial testing advisor. And so it goes in and scans what I've done in a project and says, what level of testing am I missing? What other kind of testing could I do to make sure it's that? And I just use the built-in capability to build skills within the CLI. And I just told it what I want to do and use the brainstorming skill. And it, talks back and forth with me and uses that Socratic method to come up with what I would actually want the skill to do and generate the skill in the right format. So you could all replicate these skills in probably a day.
Gotcha. Is your adversarial concepts all your own, or are you pulling that from any other research papers or research areas?
I actually, when I was working on the math proofs, I would go through and I'd work with it for hours, and the AI would be like, "You did it! You solved the 400-year-old problem." And then I would say, I'd go to a different AI and I would feed in what I would done and say, "I want you to do an adversarial, skeptical, journal review, mathematician, check of how correct this is to the highest math standards." And it would go off and do its thing. So I kind of came up with that concept while I was doing that. And then as I was doing the coding here, I was like, that same thing will probably work. So other than all you have to do is just say, hey, do an adversarial review of the implementation plan. And it will do it. Or you can, like I just talked about building a skill, have it build a whole skill for you that'll be even more, complex. But it's pretty good at wanting to please you, as I said. So if you tell it to be adversarial, it'll be adversarial.
Yeah, I've totally noticed that.
All right, let's go to somebody in the room then. We're going to try and spread it around. We have more questions in the room. Go ahead.
So let's say I'm doing like some coding with Cursor, and this like system you described, should I like create different files, like markdown files, and define my projects, like guidelines and security review, like different files, and refer to them whenever I want to do something?
Yeah, you're talking about like the project artifacts and that sort of thing. Yeah, so like my documentation map and my project map and that sort of thing. Definitely, for those sort of artifacts, keep on disk and that sort of thing. As far as like what a security review consists of, at this point, I would probably encourage you to turn it into a skill, but you can keep it on disk. I keep like, if I'm building an install bundle or an upgrade bundle for my application, I have a file that says, hey, here's the process that I want you to follow for it and that sort of thing. So I haven't turned it into a skill, but whenever I want to create the bundle, I just say, hey, reread this to make sure you remember the process and all the mistakes we've made in the past in building the bundles, and then generate me a new bundle. and it'll go off and do that. So I don't think there's necessarily a right answer. It's just what kind of works for you. I've also kind of been working on, so if I change a file in the source code, that file depends on other files and other files depend on that. And depending on the language, a lot of that is kind of easy to find as far as the language, like function calls and that sort of stuff. But it's hard if you're like surfacing an API and something else over here calls that API. You're not going to find that by trying to do dependencies. So I've been trying to work on some tools that'll scan your code base and find those linkages to further feed into the AI, so it knows like, hey, if you're changing this, you need to really also focus your testing on these other parts of the code to make sure you didn't break something.
All right. Thank you.
So
Oh, it's on.
is it on? Can you hear me? Okay. So my question is about, so I, did a lot of distributed systems programming back in the day. And then this kind of morphed into something that we referred to more modernly as like flaky tests, right? Where tests have kind of non-deterministic outcomes.
Right.
And I can't decide if those tests will be easier in this context to find and resolve or harder. And I can't, because I feel like AI might actually gaslight me on some of these tests if I let it.
Yeah.
So I'm just curious if you had any experience with those or advice for managing that kind of.
Not specifically, but I would imagine the advantage that the AI has is it's better at interpreting the results for you. So before, we might write a script and it would test something and you might have something else trying to like parse those results. And so our ability to write a Python program that could intelligently parse what it is if there was a variety of responses that came back versus the AI being able to parse that result. So as far as coming up with the flaky tests, it'd be interesting to try it out. But I do think it would give you that advantage in analyzing the results from the test.
Since you mentioned about like proof-based, you've been working on proofs, mathematical proofs and stuff. I'm following a lot of mathematical formal proof-based AI outputs and stuff. And I mean, I've been listening to talks from Amazon's leaders talking about how they're using proof-based maths for secure applications. Or like, what is your take on it? Because whenever I listen to that, they're obviously going to say that because it's their product that they're selling, but I want your take on it.
So in math, when I was doing that, have you heard of lean?
Yeah.
Like a verification.
I've been working on that.
Yeah. So I started in the math to build the systems around it, where I would like tell it to brainstorm, come up with 20 approaches that may be something new for this. And then I tried to build a kind of a machine within the LLM to have it recursively go down each of those ideas and solve parts of it until it decided it was a dead end or not. And then as part of my verification, I didn't necessarily have like a math linter. I would try to get the LLM to code whatever it was trying to prove in lean to give me, as a non-mathematician. Ironically, I kind of flushed out of math at number theory, and then I've been doing trying to use the LLM to do number theory. But yeah, so I tried to approach it there. There is a language, and I'm drawing a complete blank, that I've seen some talk on Twitter about using to verify code with. So I think there's a kind of similar concept that you could apply to code to prove its correctness, and probably around like state machines, if I remember correctly. I just don't remember the name of it right now, but I haven't gotten into dabbling with it yet. But yeah, that'd be great, to add into this kind of process and say, hey, now build, an actual state machine to prove that what it's doing is correct.
Are you trying to incorporate some of these methods in your organization for security?
Yeah. So we definitely. It's interesting in the government. They don't always move at the same pace as other organizations, and so getting them to allow you to use the AI to help in that sort of thing. Definitely, we're using it on the products that we're building to help us do kind of the generic scans of the software. And then I also have like a CI pipeline of various scanning tools that I run against the code and do linting and build an SBOM and make sure all the packages are the latest packages and there's not any updates and that sort of thing. So we build in a lot of that security type of work into the process.
Thank you so much.
Yeah, oh, there's one.
Thank you for your talk. I have a slightly, I guess, more philosophical question about the use of LLMs in general for engineering. So I do a lot of I read a lot of ML machine learning like research papers, and one paper that stuck with me recently was I think it was a paper that won best paper award at NeurIPS in 2025, and what they basically showed was that LLMs exhibit a large degree of homogeneity, in the sense that if you take LLMs, even across different families like the ChatGPT, Claude, and you ask them the same open-ended questions, like write me a poem about XYZ, most LLMs will generate a poem that sounds the same, like they have the same entities, the same relationships. And that kind of got me worried about the use of LLMs in engineering. So like I use, and that's not to say I don't find value in the use of LLMs for coding. Like I was in denial for a very long time about how good Claude Code was until I tried it like last week, and it's amazing. But I'm worried if you, well, no, sorry. My question is like, do you kind of share this concern that by depending on LLMs too much long term, we kind of homogenize the creativity in engineering? Because a lot of times,
yeah. So you know, if you ask it to tell you a joke, even the same LLM, if all 5 of us ask us to tell a joke about something, it's probably going to give us a pretty similar joke. Like it's been trained to almost pick the average and go with it. Some interesting things I've read. Now, I'm definitely not an LLM building engineer, so I'm not the expert in all of that. But is if you can put it into more of a statistical context of probabilities, that it'll break itself out of that merging to the center. So I haven't fully fleshed out exactly what that means, but I think, you know, it allows you to kind of free it from some of that groupthink, if you want to call it that, for if that's an applicable term for an LLM. And more generally, I think, you know, my whole point of artifacts, like the AI is great, but you trust but verify. You need to see the artifacts that it ran the test, and you got to verify the tests are doing what you think they are, and still having the human go in and do, you know. So we don't 100% trust it to do anything. We want to go through and put in those engineering guardrails to make sure we get the results we think we're getting.
Yeah, you briefly mentioned in your workflow about paying for APIs versus using the chat window. And I was curious if you had any thoughts on projects like NVIDIA Spark, which are trying to get AI hardware running locally on people's desks.
Yeah. I'm very interested in getting my own DGX Spark machine. So I think the issue will be the speed. You know, I was talking actually to our AI practice lead yesterday. He has a DGX Spark, and I was asking him how he liked it. He said it's good for like Claude Code, or not, what is it, Nemo Claw and Open Claw and those sort of things. It's definitely not as fast as you're going to experience using, you know, Gemini or ChatGPT or Claude Code or that sort of thing. And he was saying, you know, really you need to get some video cards, like 3 or 4 video, that same sort of memory, and it would crush the tokens per second, but it's going to cost you, you know, 5 times as much to do it that way. And with the subscription, so the like Claude Code or Gemini or all those sorts of things, you can either, you know, you can go to the API and pay per API call, or you can get the subscription. So beyond just using the web interface, you know, where you use it, it acts exactly the same way. It just gives you a certain amount of usage over the week, and you got to make sure you don't go past that, or else you have to start paying with the API. But it's not just the web interface.
Thank you.
Hi. Yeah. So I too work at a government agency, and as you know how it goes in the government, I one day woke up in the morning, went to my boring job, and found out I'm now the manager of like a gigantic LLM system for the agency-wide implementation. As it goes, I have three customer bases that I largely have to uh, work with, which is one, my bosses who listen to so many podcasts, they've started wearing black turtlenecks. Two, the actual vendor I work with who, they always find reasons that they can't do something. And three, the analysts who every false positive causes them to think it doesn't work at all and everything's broken. I really like some of the things that came up in this talk. But as a prior analyst yourself, how would you modify, they don't write code, but how would you modify some of this workflow and some of the things you discussed today in developing a systems approach to how analysts could implement this design, this design?
Yeah. So I'm actually building an anomaly detection product at work right now, and I'm adding in an AI component to it. So I have the AI run container, and then you find something. Anomaly is not good or bad. It's just an anomaly. Want to have the AI look at it. So it really comes down to thinking about what the AI is good at. So at first I said, okay, well, tell me if it's benign, malicious, or suspicious. So the AI model that I could get and run locally, because a lot of people don't want to send sensitive security information off to a corporate entity that who knows what they'll do with it. With a local model, it just was not very capable. I would get, maybe 50, 60% error rates. And so I switched it to first just explain to me what happened. So I'll give you the evidence of what the anomaly was. Somebody logged into this box, they ran these commands, it opened these ports. Give me the explanation of what you think it is. And AI was great at that. It's like 90 something percent giving that. And then I would say, does this match a obvious malicious pattern? So, and I could give it some examples of some, and then it's pretty good at that. So if you kind of take different parts that it's good at and try to kind of lash them together versus trying to get it to do the whole thing that you would maybe want to do it. I've really been, Elon Musk and Steve Jobs and a lot of them talk about first principles and breaking things down to first principles. And I've found some good prompts online that really take whatever you're looking at and break it down to first principles and then bring it back up. And that's kind of what I did with that AI thing, was saying, given the limitations of what I have, how should I structure these prompts to get the most value for the analysts? So I'm kind of rambling. I don't know if I answered your question or, but, happy to talk more about it later if you want.
Yeah, I think we're out of time. So let's thank our speaker one more time. Thank you. Doesn't matter what order.
Okay.